We are going to talk today how we created Google Maps Navigation SDK for Flutter and about technical choices and what we felt important behind of the development. About me, I'm Joonas Kerttula and I'm a lead developer and software architect at CodeMate. Our team has been making contributions to following Flutter plugins in the history. Google Maps Flutter, which we have implemented ground overlays, clustering, and improving the marker scaling. And then we have started from scratch Google Navigation Flutter and Google Driver Flutter package, which is still private. Few slides are material from Google Maps partner material explaining what Navigation SDK is for Android and iOS. So Google has created Navigation SDK for Android and iOS platforms. What our plugin does is implementing those platforms using native implementations. Google Maps mobility services consist of Navigation SDK, Driver SDK, Consumer SDK, and Fleet Engine. Those solutions helps your drivers navigate more efficiently, making their performance more predictable and optimizing their routes, what they are following. And also these SDKs improve app usability as navigation is part of your application. In normal situations, when you want to have navigation in your application, you have an external link which opens Google Maps application where users navigate. But these SDKs brings the navigation to your application like Google Maps Flutter does. And driver routing and navigation allows optimization and continuous routing improvements while drivers are navigating. So it's always tracking traffic and things like that and gives you better routes while you're navigating, like Google Maps official application does. And it also allows developers and companies to use real-time data to optimize their business. It means that the driver SDK is sending data to Google Fleet Engine, and the backend solutions can read the data from there and optimize the driver and their driver routes and their own business. So, what is Navigation SDK and how we created Google Navigation Flutter? So, this package is still beta. We are under active development. We are creating new fixes and improvements to the API each time new API and SDK versions came out. And what this allows is the cross-platform app development with navigation features with Flutter. This is normally not possible without having custom overlays on Google Maps Flutter application. So this SDK allows the navigation using the official Google APIs. Features of the plugin. So developers have way to start navigation sessions without any navigation views and widgets. So navigation is separate component, and you start the navigation session by starting the navigation, giving destination, and starting the guidance of the navigation. Then this supports navigation views and map views. Navigation view can be attached to the existing navigation, and it shows the navigation path in real time on the map. This separation is done because this allows Flutter developers to change views without showing navigation view, and the navigation continues in the background. And it's always possible to attach back to the navigation session. Map views are separated because it's possible to use only maps without navigation features, and it allows to create map views with, for example, locations of your business and things like that without having the ongoing navigation session visible on the map. It also supports listening turn-by-turn events, allowing custom navigation overlays. So you can hide the overlays which are coming with the navigation view and create your own depending of nav info data coming from the plugin. It supports simulating the navigation route. This is really important for development purposes. So when you start the navigation, you get the route and you want to test how the application works when that route is simulated. And it also supports CarPlay and Android Auto integration, meaning that for cars that support CarPlay or Android Auto, it's possible to open the navigation on those screens as well. And we have also driver SDK extension for this navigation SDK plugin. So when we started this development, we had important priorities for navigation SDK package development, meaning that we wanted to have unified API across platforms. This means that for every API, users don't have to test that if it's iOS or Android, they can just use the methods, and they should work the same way on both platforms. There are some flags and some features which are only made for one platform, but mostly we have been able to create unified API. And this is crucial because on iOS and Android SDKs, official SDKs, some areas are made differently, and this Flutter API combines those to the same API. So how we started the package architecture, we had a few choices. Federated plugin structure was our first option. This is used by official Google plugins, and it allows to separate the package for platform interface, platform implementations, and up-facing interface and API. So in minimum, our project would have had 5 different packages. It's really good for broad platform support, meaning that if you don't know if there will be new platforms or different developers would implement new version of the plugin, and it allows to endorse plugins later and extend the plugin implementation. But it increases the boilerplate quite a lot. You have to write documentation, tests for every package. Each individual package needs to have own unit and integration tests. Option 2 is single package structure, and because Google Maps Navigation SDK are available only for Android and iOS, it's a mobility SDK, and there aren't a lot of mobile platforms. So the focus for us was that there won't be new packages and core platforms in the near future. So selecting this single package structure helped us to avoid complexity and by not writing multi-package testing and duplicated efforts across app-facing interface and platform packages. So this was our selection, and for good reasons. For federated package structure, it's really good, but for our purposes, this was much better choice. Unified API across platforms also consists bridging Dart and native. We had a few choices. Let's talk about method channels first. So there's up-facing API, then there's a platform interface which is Same interface for up-facing API for all platforms. And then there are Android and iOS implementation for that interface. And under that, there's a native communication. One way to do that is using method channels, which means that there has to be data serialization between the native and Dart implementation. And the other choice was FFI, which uses JNI Gen and FFA Gen to generate those layers. And to selecting best approach between these two, Dart FFA using FFA Gen and JNI Gen and method channel and data serialization, we had two choices for data serialization for our method channels: Pigeon, which was quite new at the time, and protocol buffers. Both FFA Gen and JNI Gen were experimental and missing a lot of features at the beginning of the project. And we tested that a while and decided that it's not ready for application development yet. So our choice was method channels with Pigeon. Our application and SDK holds about 200 host API methods over Pigeon. Host API are API layer which allows to call native commands from Dart side. And Flutter API methods are event methods that are coming from the native side to the Flutter side. For example, maps events or navigation events like which are happening real time. And then we have 40 data transfer objects, meaning that in Pigeon you have to have data transfer objects where you convert the data in both code, Android and Dart, Dart and Android and iOS implementation. For future development, I have to say that method channels are fast enough. They are really fast. Application works really fast in the release mode. There isn't really reason to refactor the current implementation at the moment. But in the future, possibilities are Dart FFI. Now when the new improvements have been coming for FFI, there are possibilities to do native code assets soon. And it allows to do synchronous API calls in the future. It's not mandatory, but in some cases it might help to mitigate some race conditions on the code base. Also, method channels with Pigeon. There's after our initial implementation, there's a new API method, proxy API. This allows to move the instance initialization to the native side. It uses like proxy objects, and the communication is done so that every data is mapped to the native objects, allowing creating like a more solid state handling in the native side. And for some objects, this could be easy change over the Pigeon API and could improve the quality of the package. Next important area for us was documentation and samples. About documentation, we see that well-written README MD is the most important thing. You have less errors, less issues, and less support questions if you have good documentation and good public documentation. And every public method and channel has to be, class and method has to be documented really well. And it's just nice to have core part of the user experience because it builds the trust between developer community and reduces the number of issues. We have used the effective Dart documentation plan, and I have to say that the Dart doc documents can be created really well. We have used, for example, categories for different areas, you can have separate functions for map views and navigation views and have categories for those. You can see those colors on the classes, meaning that some classes are for certain categories and so on. It also allows to create own main cover view for each category if it's necessary and useful. About example application, you should always have fully featured example application. It should always show every method and every functionality you have in the application. And it's really important to introduce how to use the application and best practices. This also removes a lot of issues and bugs, and also when the bugs is reported, you can ask them to test that in the example application. If it works over there, the bug might be something related to user implementation. Example application is actually available on our booth if you want to check that on the phone how it works and test the navigation SDK over there. We have also support for Android Auto, Apple CarPlay and driver SDKs. And let's see if it starts the video. Yeah. So here you see the example how Android Auto works with the CarPlay. Developers can have like a CarPlay screen visible and see in the real time how navigation works on that. It's done with the CarPlay emulator on iOS. It also we have made that so that we have a base class for developers which automatically communicates with the navigation SDK. So developers can control the navigation view visible on their CarPlay screen within our Flutter API. Then I have video. I will talk about how we extended the package for driver SDK. So driver SDK is not currently available for public. You have to contact Google Maps sales to have access to this API, as this is meant for their customers. It's a separate package and it depends internally on this Google Navigation Flutter package. It has own method channel implementation with Pigeon, allowing developers to attach driver and vehicle to the navigation session. And Navigation SDK exposes access to Navigation Session Manager for this SDK implementation. And there's a simple code example how it's done in the driver SDK in the native side. On Android Kotlin code, so you just import the package from another Flutter package and it's available if it's made public, and you can control that over there. Really simple and really easy to use, but you have to have separately exposed methods to allow this. On Flutter side, communication, of course, is available with the package directly. On the driver SDK, there's a support for few different kind of tasks. You have scheduled tasks, which allows developers to have paths. For example, courier companies or companies that move a lot of data packages from different locations to separate. Drivers can have a way to check the checkpoints, and the fleet engine has handled all the routing for different points and optimize the driver routes. And then there are on-demand trips, which means that this is for companies like Uber or taxi companies, which take people to the ride and drop them to different locations. And there's own API and for that in the driver SDK. And these all are available with this Flutter implementation for driver SDK. Next area is good test coverage. It has been really important for us that every public method is tested. It ensures reliability and performance on the development. It resolves and identifies issues early. For example, if new SDK update is coming from official update or any dependencies update, we instantly see that it's if it's working or if it's not after the update. So it prevents regression quite a lot. And also it enhances the code maintainability. So for unit tests, we have implemented all the branches of all individual components. We use mock dependencies where it's needed and dependency injections when available. And using unit tests, it ensures fast execution instead of using integration tests for everything. And for integration tests, we test complete workflows and simulate real user scenarios. For navigation SDK, integration tests are a little bit tricky because navigation SDK use real-time map data. For example, when you navigate from point to point, at sometimes in the integration test there might be traffic and sometimes not. So we have to be really careful where we test those areas in the map. So we have selected areas on the world where never have traffic and things like that. So, and also we have really tight rules how to test things so that test won't be flaky all the time. So it's really important that the tests pass, otherwise you will have always blocking PRs. So tests for real, like these plugins, might be complicated if you have native components. And to fix that, we have used Patrol library, which allows to click some native elements. For example, navigation SDK at starts dialog and asks permissions to use the navigation SDK, and that has to be accepted by every user. And so in the integration tests, we have to click that button and continue. Also, we have to give permissions, and this can be used to do that. Patrol is made by Lean Code, and it has been really good package for us, but there are other solutions to do this as well. About code quality, this is also one area we felt really important on our development. And our package has followed the official Flutter repo style guides. And I suggest that every package developer should go through those, because they are really good and allows to use same code style Google is using in their own packages. We have used automatic linters for all languages and formatters. So each time commit is made, it has to be formatted, and we check that in the CI as well. We use Dependabot to keep plugin dependencies up to date. This consists also Kotlin, Android and iOS packages, but also, of course, Flutter packages. And like these are common sense, but each PR must be approved and reviewed by another developer. And also one important thing about the quality is that we have and reviews and community PRs is that we have created templates in the GitHub, which means that you can create different templates for different scenarios. For example, bug template would be different than issue template. Mostly you should use the default template because people doesn't give enough information. When you use these templates, you can have different text fields for different information, ask certain data for developers. For example, Flutter doctor output and code samples and what version of the plugin they have used and things like that, which helps a lot to find out the issue, what's behind the issue to start with. And it was much shorter than I thought, but thank you. And I hope that you have questions. And if you have questions, use the microphone. Thank you. Yeah. Yeah. And also, if you want to test the example application, you can come to our booth. I have iPhone there, which has running applications, so you can see how it works. Thank you.